Students, good evening. Will you able to hear me? Is it clear, my voice?
Yes, sir.
Yeah. So sorry for the yesterday, so it's dropped in the middle. Yeah. So we are doing the differentiation. Anyone can brief what we are doing in the differentiation yesterday? I already done one numerical related to the differentiation. Yeah, please continue. I done a numerical, find the differentiation of the function at x is equal to 0, where f of x is equal to sin x, correct? Find the differentiation of function at x is equal to 0, where y is equal to sin x. So, if x is equal to 0 plus h, y will become f of x plus h. At x is equal to 0, where y is f of x. So, limit h tends to 0, f of x plus h minus f of x divided by x plus h minus h. That is only delta y by delta x if delta x is tending to 0. So limit delta x tends to 0, delta y by delta x is equal to dy by dx. This meaning is the rate of, guys, 1 second, the call comes, yeah, sorry, okay. The rate of change of y with respect to x. The meaning is, if there is a change in x, how the y is changing at that location, at that point. It is different at different points at different functions. In case of straight line, it is fixed, but in case of curve, it might be different. I will show you graphically what is the meaning of differentiation. Is it clear what is the significance of differentiation in physics point of view also? Is it clear, students? Guys, I'm waiting for your response. Yeah. Now, I already done yesterday. Anyone can do, and can you, yes, I'm giving the 2 minutes time. Anyone can give the answer for this question. Anyone can give the answer for this question. I done yesterday. I need the answer for you, from you. What is the answer for this question? If you remember yesterday topic, I explained beyond what you want also. What is the meaning? Why we will take sin theta is equal to sin theta is equal to theta for smaller angles. Sin tan theta is equal to theta for smaller angles. Why? And in limits, sin theta by theta is equal to 1. Limit theta tends to 0 is equal to 1. Why? With respect to differentiation also, I can explain using this. Yeah, I'm just waiting for 2 minutes.
Sir, can I say?
Yeah, guys, please. What is the answer for this? What is the answer?
Sir, cos x.
Cos x. Cos x. So I'm asking that x is equal to 0. So substitute x is equal to 0. What is the answer? 1.
1, sir.
So f dash of 0 is equal to 1. This is a symbol will be useful for differentiation. This is a symbol. Generally, they will use f dash of 0, y1, y dash, y1, dy by dx. This is nothing but dy by dx of the function. That is the meaning of the symbol. This dy by dx, you can't split like dy is numerator, dx is denominator. It's not like that. This is the symbol for, this is called differential operator. The meaning of dy by dx is called differential operator. It is a differentiation of one function. If there is a change in x and this change is even though very, very small, infinity small, then what is the change in y? That is the meaning of differentiation. Now, we will see what is the meaning of graphical representation of this one. So, graphical representation, there are many, but I will explain with a little bit few. Suppose if I'm taking a function, guys, anyone can give up your own standard algebraic functions or some other function, your wish. Anyone can give the function to understand the differentiation of the function at different points.
Tan x, sir.
Tan x. So I'm taking tan x function. So I'm zooming out to understand a little bit more. Yeah. So I'm taking the wind screen of this one, and I'm trying to explain what is the exact meaning of differentiation in the graph. What it says. This is the function. Suppose if I'm taking, I'm asking what is the change of y with respect to x at x is equal. We can give any values, guys. You can give any own values. Suppose if I'm taking, this is 90 degrees. This is not, this is 90 degrees. This is 90 degrees will come, it seems. I will change the graph parameters here, then it will be easy to understand. Graph paper. Trigonometry. Yeah, now it is a little bit clear to understand if it is in angles. Yeah. Now, if I am taking, this is a graph of the one standard function. If I am taking, if the x is changing from 0 to some small value, from 0 to 0.001. So if it is changing from here to here, so what is the corresponding change? So just to understand this one, I'm zooming this one. Yeah. Yeah. If I'm changing the x, a small value from 0 to 1, when 0, at 0, this is 0, at 1, it is here. So this is the change in y. Suppose if it is changing from 0.12, suppose this is 0.1, this is 0.2. At 0.1, this is y value. At 0.2, this is y value. So this is a change in x. The corresponding change in y is like this. This much as the corresponding change in y. But the same change if I'm taking here, looking to here, the beauty is, even though a small change here, so the change in y is little bit big. That means it is not a linear. Suppose if I'm changing, if I'm taking the change here, if I'm taking the change here, see here, even when it is approaching 0.5, that means at 5 by 2, even a small change is giving a lot of increment. See, if I'm joining here, the function is increasing undefined. Suppose if I'm taking very small change here, it will meet somewhere. I don't know where it will meet, and it will meet somewhere here. So this is a change in y. So this much of change, even though the same change if I'm taking. Got it, guys? What is the meaning of differentiation? So this function is behaving differently. If there is a change in x at 0.1, it is at this point, the change in y is different. At this point, the change in y is different. When it is approaching at infinity, like when it is undefined situation, the change in y is very huge. Randomly, it is increasing. So unexpectedly, even the small change in y at pi by 2, even though if there is a small change in x will use a big variation in y. So to understand the behavior of the function at different positions, it is not so easy by graphs because each and every point of suppose here I can plot and I can zoom out and I can take something. But if I want to do without graph analytically, we will use the concept of differentiation. And also in physics, importantly, how the curve is bending. What is the meaning of curve is bending? Suppose if I'm taking the graph here, this is nothing but slope. The particle is moving in this direction here. When it comes to here, the particle is moving in this direction. But when it comes to here, it is there. When it comes to here, even though small change, the particle is moving in a straight forward. Almost the particle is moving in a uniform constant. If it is traveling on this, between here to here only, there is a much change in direction. But beyond this point and beyond that point, there is no much change in the direction. That is one way of explaining the concept of differentiation in physics. So the scope is huge. You can connect to many places with respect to the differentiation of graph. Is it clear, students? Anyone having any doubt?
No, sir.
Is it clear?
Yes, sir.
Yeah. So I will start with some few numericals. The second thing is, if I am using this formula, if I am using a limit and I am solving the differentiation of a function at particular values, that is called differentiation of a function using the first principle. Yeah. So now I'm going back to the things. We are having only analytical method to solve even in +2 also. We won't discuss this much of it. It would be useful for your physics. If you understand the differentiation properly in physics, many topics will be very much easy for you people. You won't hesitate to understand the concepts. So learning is only for understanding and knowing the things, not for marks. But in India, we need marks. That's the second point. I will start with the question. See, whatever questions we are doing, it is not much scope for your +2. Just it is not. It will be useful to understand the what is exact meaning of differentiation. This first, how we can define the differentiation. One way of explaining the differentiation, if f is a real valued function. So you understand whatever the function your differentiation, it should be a real valued function. F is a real valued function and A is a point in its domain. And A is a point in its domain. It's very simple. If A is increased a little bit also, what is the change in function is called differentiation of the function at A. The derivative of or the differentiation derivative of f at A is defined. Suppose if A is increased by h, where h is almost equal to 0. So the change in function for new value minus initial value divided by a plus h minus h, limit h tends to 0. So this will use limit h tends to 0, f of a plus h minus f of a divided by a. Sorry guys, h plus this is a, this is h. This is called provided this limit should exist. Limit exists. You know what is the condition for limits existence? Left hand limit, right hand limit must be equal. Then only differentiation can exist. So derivative of f of x is denoted by f of dash a, or d by dx of f of x at x is equal to a, or d by dx of f of a. Anything is same. Or if I am representing y is equal to f of x, dy by dx at x is equal to a. If I am not mentioning this one, you are just doing the differentiation for any situation. You are doing the differentiation for any point. So shall I proceed for some numericals, students? Students, I can proceed for some numericals.
Yes, sir.
Yeah. Find the derivative of the function f of x is equal to 2x square plus 3x minus 5 at x is equal to minus 1. Please do this question.
Sir, do we take pen? We take a different scale.
One. Am I having the scale? Why did it take scale? Guys, please complete this question. It's a simple expression I gave. I draw with this one.
Oh.
Yeah, students, please. I need the answer.
Four x plus 3, sir.
4x plus 2. 4x plus 2. Is it 4x plus 2, man? Are you using that
No, sir.
method?
4x plus 3, sir. And we have to substitute the
In the
value.
differentiation, you have to substitute minus 1. Yeah, that's why we are going with first principle. We are not
Minus 1, sir.
Yeah, minus 1. How to do using the first principle? That means how to do using the definition of this function. So they are asking f dash of minus 1. That is nothing but differentiation of function d by dx of f of x at x is equal to minus 1. Both are same. The way how we will represent its evaluation. Limit h tends to 0. F of x plus h minus f of x divided by h. This will be limit h tends to 0. What is your x? Minus 1 plus h minus f of minus 1 divided by h. So limit h tends to 0. How you write? 2 into minus 1 plus h whole square plus 3 into minus 1 plus h minus 5 minus, if I'm substituting minus 1 in that, 2 minus 3 minus 5, correct? 2 minus 3 minus 5 divided by h. What is your answer? If I'm substituting h is equal to 0, 2 of minus 1 whole square plus 3 of minus 1 minus 5. So what's your answer? I'm getting everything is becoming 0 there. No. Everything is becoming 0 here. You can substituting directly. So what you have to do here, students?
Sir, we can substitute the value later, sir. First, we can
Yes,
find the limit.
expansion. 1 plus h square minus 2h minus 3 plus 3h minus 5. So minus 2 minus 3 minus 5, 2 minus 8 minus 6 divided by h. So this will be plus 6. This will be 2h square minus 4h minus 3 plus 5. So minus 3 minus 5 is minus 8. So minus 3 minus 5 minus 8 minus 6 minus of minus plus 6. Finally, I'm getting, if I'm adding 2 inside, 2h square minus 4h plus 3h by h. Limit h tends to 0. If I'm applying infinite, h cancel, h cancel, h cancel. So this will be limit h tends to 0 minus 4 plus 3 minus 1. 2h minus 1, which is equal to 0 minus 1. The answer is minus 1. This is how you have to do if they ask you about the first principle. But this is a little bit longer method. So instead of avoiding this one, we will do some fixed formula for each standard functions. We are going to discuss the Nitish, you are asking which step? Can you repeat the before step? Sorry, now only I'm seeing your message. Second step. Second step in the sense, this one. Limit h tends to 0. This one. Correct? Yeah. What is the definition? Definition of a limit is what? If I am asking find the differentiation of a function at x is equal to a means what? Substitute f of x plus, sorry, a plus h. That means x is equal to a means limit h tends to 0, f of x plus a minus f of a divided by, sorry, x plus h, f of x, f of x plus h minus x. So this is the definition of the limit. Limit h tends to 0, f of x plus h minus f of x by h. If I am asking, this is f dash x. If I am asking f dash of minus 1, wherever you are having minus 1, you substitute here. Limit h tends to 0, f of minus 1 plus h minus f of minus 1 divided by h. But what is your f of x? What is your f of x? Then that is a given question. What are the function they are giving? That is your f of x. What is your f of x in this case? Your f of x is 2x square plus 3x minus 5. 2x square plus 3x minus 5. So wherever you are having x, substitute minus 1 plus h. This meaning is wherever you are having x in the function, you have to substitute minus 1 plus h. Now are you clear? What is that step says? Minus 1 plus h whole square plus 3 into minus 1 plus h minus 5 minus 2 of minus 1 whole square plus 3 of minus 1 minus 5 divided by h. If we expand, if we cancel certain things, finally I'm getting, after substituting h is equal to 0, minus 1 is the answer. Will you clear, Nitish, now? Yeah. With respect to this, how we can discuss the definition, another definition of the differentiation. It's the same way. If f is a real valued function, if f is a real valued function, the derivation of the function limit h tends to 0, f of x plus h minus f of x divided by h. Wherever the limit exists is defined to be derivative of f at x and denoted by f dash x. This is denoted by f dash x wherever the limit is, at what are all the x values the limit is defined. So the definition of their derivative is also called first principle. If I'm deriving the differentiation of the function at x might be anything where the limit exists. So that is called first principle. First principle of derivative. Suppose if they are asking first principle of derivative, we have to do it. What is the use of this first principle means each and every time, each and every thing we can't. In physics, we will get what is the differentiation, rate of change of velocity. They didn't mention any value. How the change function, rate of change of velocity. Suppose if the graph is like this, if I'm taking the change in x, it will be like this. If I'm taking here, this is a small change in y. If I'm taking in x, even though there is a change in x, there is no change in y at this point. Here, if I'm taking the change in y is constant. Even x is changed from here to here, here to here, here to here. The y is like a zero change. So here, if I'm taking any value from here to here, the differentiation is zero. There is no change. The differentiation is constant. Constant means, differentiation is zero. Zero means no change. Differentiation is constant means how much it is changing. Generally, this is the differentiation is constant. From here to here, suppose if I am x is increased by 1, y is increased by 2. If x is increased by 1, y also will increase exactly by 2 at any position. But in this case, it is not like that. See this point, different values of x, the y is different. Even though here x is increased by 1, the change in y is y1. Here x is increased by 1, the change in y is 0 here. Guys, 1 minute, I will put the charge. Understand guys, what is the meaning? So to understand this variation for all values of x, we will use the first principle. So each and every time we can't use the first principle and we can't substitute the values. So to understand the variation, we will find out the differentiation for all positions. So the rate of change function we are going to discuss using the first principle. Suppose if I am saying a function y is equal f of x is y is equal to f of x, where f of x is equal to x. What is the meaning of y is equal to x function? Y is equal to x function means what? Y is equal to x function. If I'm looking into this function, if you observe very clearly, just I'm taking the zoom out. Yeah, it will be easy to understand from here. I will tell you graphically, I will discuss with you, and after that I will prove using the differentiation concept. Yeah, now look into this. See here, if you look into this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8. If the x is increased from 2 to 3, the corresponding increment in y is exactly 1. So at 2 to 3, x is increased by 1, y also increased exactly 1. If x is increased from 7 to 8, see here, this is 7th position, this is 8th position of x. The corresponding y is exactly 1. If I'm taking some other position, see here, 13 to 14. The y also increased exactly 1. If I'm increasing 2 units, y also increased 2 units. That means the change in y with respect to x is fixed. If x is increased by 1, y also increased by 1. If x is increased by 2, y also increased by 2. Per unit, it will be 1 only. Suppose same function, if I'm taking x square function, look, I'm taking x cube function, for example. Y is equal to x power 3. See this function. I'm zooming out for understanding purpose. It will be very simple to understand this. In this case, it won't work like that. Suppose if I'm taking the particular value, see here, when x is increasing from 0 to 1, the y is also increased from, suppose if I'm taking x is increased 1, this is 2. When x is increased from 1 to 2, 1 to 2, so if x is increased by 1 unit at 1 to 2, at 1, it is increased by 1 unit, the y is increased 6 units. Suppose if I'm taking a function here, see here, I have to zoom out to understand this one. If I'm taking between 4 and, sorry, between 3 and 4, where 3 is meeting, see here, where 3 is meeting, the 3 is meeting, this is 3, the 3 is meeting somewhere at 25, and 4 is meeting somewhere at, see, at 55. That means at x is equal to 3 to 4, the change is only 1, the delta x is 1, but in this case, the delta y is some, how much it is changing? Somewhere it meets at 62, and at 13 it is meeting at 20, I can take it as 25 plus 27 or something. So delta y is 27 to 62. So how much change it is? Very huge. So if I'm taking some 6 to 7, it will be different. Randomly it is changing. It is not same like here also x is increased from 3 to 4 to 13 to 14. Here also x is increased by 1. Here also x is increased by 1. Here also x is increased by 1. But the change in y is different at different locations. But always I can't discuss like this. And always I can't give the particular points. That's the reason we are preparing a standard formula. If there is a change in x, how this function will behave. So that we will do using the first principle. Is it clear, guys? Little bit more precisely what is meant by differentiation to understand the physics concepts. Clear or not? Please.
Yes, sir.
Yeah. Now the question is, find the differentiation of 10x using the first principle. Find the derivative of function f of x is equal to 10x using first principle. Guys, please let me know the answer. Guys, please do it and let me know the answer. The answer is 10. If you people who already done the differentiation, they can say directly. The answer is 10, but I need with respect to first principle how to do. That is a little bit important. Might be board point of view, you might feel it is not much important, but a concept point of view, it should be there. When you are thinking the graph, it should be so now we got why you're taking different routes.
No, R 1.8. This one is not. function. Why over here?
Students, anyone got the answer? Using the first principle, anyone got the answer? Using the first principle, anyone got the answer? F of x is equal to 10x. He's asking f dash of x. He didn't give x is particular value, just at any value of x, where the limit exists at that x value, what is the differentiation of 10x? So according to definition, f dash x is equal to f of x plus h minus f of x divided by h limit h tends to 0. This will be 10 of limit h tends to 0, 10 of x plus h minus 10x divided by h. This will be limit h tends to 0, 10x minus 10x plus 10h minus 10x divided by h. So 10x cancel. So limit h tends to 0, 10h by h, which is nothing but h cancel. Limit h tends to 0. Sorry, proper limit the 10. So the d by dx of 10x is nothing but 10. Or you can write as f dash of x, that is f dash of 10x is equal to 10. Using this, I can say the d by dx of some constant into x is nothing but constant. This is one fixed formula we will use in many cases. Suppose I am saying e by dx of kx, where k is some constant, the answer is k. This is the first formula, you can keep it in mind. If I want derivation for the kx, I will show you to you. Students, clear?
Yes, sir.
Find the differentiation of the function where f of x is equal to x square. Find the differentiation of the function where f of x is equal to x square. You can do it directly if I'm asking like this. But if I'm asking like this, you have to use the first principle. Find the derivative of function f of x is equal to x square using first principle. So my f of x is equal to x square. So f dash x is equal to limit h tends to 0, x plus h whole square minus x square divided by h. Limit h tends to 0, x square plus h square plus 2xh minus x square divided by h. So x square cancel. Limit h tends to 0, if I am taking h common, h plus 2x. This is h cancel. So will be limit h tends to 0, h plus 2x, the answer is 2x. So d by dx of x square is 2x. Is it clear, students?
Yes, sir.
Same way, can you calculate the d by dx of, find the derivative of function x power n using first principle. The answer is, if f of x is equal to x power n, f dash x is equal to, or d by dx of x power n is equal to n into x power n minus 1. You have to get the answer like this, guys. how to do this question. Suppose actually this won't come. Why this won't come, I will tell you. Because this is based on the binomial theorem. Binomial theorem is deleted from the question. That's the reason you can't expect this kind of questions using the binomial theorem. Anyone got the answer? How to do it? Same procedure, method, everything is same. There is not much difference in the procedure and method. Limit h tends to 0, x plus h whole power n minus x power n divided by h. How to do this question? So I already told you this question we can do in many ways, but there is a formula. Be able to remember anyone the formula? Limit x tends to 0, x power n minus a power n by x minus a is equal to how much? N into x power n minus 1. Anyone can recollect the concept of limits this formula?
Yes, sir.
So what I am doing is even using L'Hospital rule also you can do many methods. Using binomial theorem you can do, using L'Hospital rule you can do anything. But L'Hospital rule is again from the differentiation only. So this numerator I am writing x plus h whole power n minus x power n. But it is not like this is your x, this is your a. So how we will make it this one? This can be written as x plus h minus x. This is like your capital X, this is your like a. This is your capital X, this is like your a. So the answer is n into x is what? X plus h whole power n minus 1, where h is 0 here. So n into x power n minus 1. Simple. Confused? But the usually, if in general, I will explain using the binomial theorem method. Binomial theorem says expansion of a, suppose if I'm having x plus y whole power n, this can be written as, sorry guys, you have to understand the meaning of NC0 and all. NC0 x power n plus NC1 x power n minus 1 into y plus NC2 x power n minus 2 into y power 1 plus and so on. NCn x power 0 y power n. So the x power decreases, y power will increase with these coefficients. What is this meaning of coefficients? We can discuss. So if I'm dividing this one minus x power n is there, so this one and this one will cancel. So after that, each and every term you are having h, because your y is h here actually. So dividing h will cancel, except first term, rest of all the places you are having the h, because this is h square, this is h cube, this is h power n. So if I'm substituting h is equal to 0, except this term, everything will become NCn value is n x power n minus 1. This is how we will discuss in binomial theorem. But as of now, we can remember limit x tends to 0. Sorry guys, not limits. Differentiation of x power n. If I'm not asking using first principle, straight away you can use this formula. Power into x power minus 1. Suppose if I'm asking d by dx of x cube without first first principle, this is 3x square. D by dx of x power 4, this is 4x cubed. If I'm saying d by dx of x power 100, this is 100 x power 99. Is it clear what is the meaning of this formula, where we have to use this one?
Sir, could you repeat the binomial method?
Binomial theorem I will explain in permutations and combinations again, man, don't worry. Okay.
Okay, sir.
So our last topic is that one, because it is eliminated. So who is interested, they will sit and listen. After permutations and combinations, you will get more clarity over the binomial theorem. Now, same way we can prove the standard functions. What are the standard functions? This is function, and this is its differentiation. This is function y. This is differentiation of y. The function is constant, the differentiation is 0. If the function is x, the differentiation is 1. If the function is x power n, the differentiation is n into x power n minus 1. If the differentiation is, the function is log x. These are the standard functions. You can remember the formulas 1 by x. If the function is e power x, e power x. All these, how we will know, sir? Using the first principle only. Log x and e power x I am not going to tell you. I will tell you at the end of the syllabus. It is not required because it is not there even in the syllabus. Log x and all won't come in syllabus. In +2 only you will touch these things. But as of now, just to keep it in mind. And if it is kx, the differentiation is k. If it is sin x, cos x. If it is cos x, minus sin x, tan x, secant x. The differentiation of cosecant x. The trigonometric ratio starting with c, that is negative, will answer. Minus cosecant x into cot x. Secant x. Secant x into tan x. Cot x minus cosecant square x. Now, I'm asking you to show the differentiation of the function of sin x is cos x. I think we already done, guys. Sin x we done. Now, I will ask for the tan x. Find d by dx of tan x is how much? Or show that d by dx of tan x is secant square x. How? Using first principle. Yes, anyone can try.
Sir, can I try?
Yes, please. Whatever the thing you will say, I will write here. Whatever thing you will say, I will write here.
Sir, it would be limit h tends to
Dash
0
of-
and
Dash of tan x is equals limit h tends to 0
tan of x plus h minus tan x upon h.
If I am substituting directly, I will get 0 by 0, correct?
Yes, sir, that is indeterminate form. So we have to use the tan x plus y formula.
No, if you use that is the longer method, I'm using this formula, see how it will get. Minus sin h by cos h. You will get, I can't say you won't get, but you will get, but it will use a longer method. So if I'm taking LCM, what you will get, man? I'm taking LCM in the numerator. I'm taking this is 1 by h like this, and I'm doing cos of x plus h into cos h, correct? This is sin of x plus h into cos h minus sin cos of x plus h into sin h. This is looking like sin a cos b, cos a sin b. What is the expansion? This is expansion for what? Sin of a minus b. Agree? Understood that step? What I done? This can be written as sin of x plus h minus h divided by cos of x plus h into cos h. Is it clear? This is a crucial step. Coming from here to here is a crucial important step. Guys, anyone having any doubt in that step, please? Students, please respond. Anyone having any doubt
No,
in
sir.
that step? Yeah. Now apply the limit now. If I'm applying the limit, what will happen?
Sir,
If I'm applying the limit, what will happen?
so you can cancel the h and then sin x upon cos x. It would become
Sin x upon cos x. But I'm
cos
getting the
x
same
plus
thing now.
h.
Limit h tends to 0. This will be, you forget about this one. When h is here, sin x, h cancel now.
Yes, sir. That's what sin x upon cos cos x plus h. Yes, sir. Into cos x. Okay, no.
Sin x divided by cos x into cos h, correct? Cos x into 1. How I am getting this one? This is coming as again tan x only here. Okay, I am applying the limit here. What you will do here? I am applying the thing, I am getting infinity. Tan x by infinity is the answer. That's not answer. You have to get the secant square x now. Secant square x means 1 by cos square x. How you will get 1 by cos square x? Yeah, this is the wrong we done, guys. Sorry. This is tan x, not tan. This is tan x. This is cos x. This is cos x. This is x. X minus x. So this is sin h divided by cos of x plus h into cos x. Cos square x into 1. This will be limit h tends to 0 sin h by h into 1 by cos square x. Understood where we done the mistake? 1 into secant square x is the answer.
Yes,
Instead
sir.
of x, we took the h. That's the reason we took. So same way, anyone can try the prove the d by dx of cosecant x is equal to minus cosecant x into cot x. This is my question. Or you can prove d by dx of secant x is equal. You can try at home. If you are able to do any kind of trigonometric functions related to first principle, you can crack it easily. So this is secant x into tan x. D by dx of cot x prove minus cosecant square x. You can try these questions. And apart from these questions, let's see what kind of questions they gave in based on the first principle. We'll see here before winding up the session. Yeah, see these questions. We done cos x. Find the derivative of the cos x from the first principle. And he is not asking first principle. You can do directly. I will tell you in next class how to do it. Yeah, again, this is a question they are asking using the first principle. These are the 4 questions are there using the first principle how to do the derivatives. You try some questions related to first principle because it's an essay question. They will ask for essay questions. So we'll do for cos x. As per formula, like I gave, sir, you can remember if they are not asking first principle, the differentiation of cos x is minus sin x. But if I'm asking how, we will use the first principle to prove this one. The first principle says the differentiation of the function. So limit h tends to 0, f of x plus h minus f of x divided by h. This is limit h tends to 0, cos of x plus h minus cos x divided by h. How to do this? How to handle this question? Same as sign. How we will handle this question? Limit h tends to 0. How will handle this question, students?
Sir, cos x plus y
Cos h minus sin x sin h minus cos x divided by how much? H. So how will handle this question? Cos A cos B minus sin A sin B minus 1. If I'm splitting into two factors. Limit h tends to 0, cos x into cos h minus cos x by h minus limit h tends to 0, sin x into sin h divided by h. This will be limit h tends to 0. If I'm taking cos x common, this is cos h minus 1 divided by h. This minus limit h tends to 0 is writing as sin x into sin h by h. Sin x into sin h by h. So what is the answer for this? Limit h tends, if I'm applying the limit, cos x into 0 will come minus sin x into 1. So the answer is minus sin x. Anyone understood how I got this is 0? Cos x, if I'm taking out, limit h tends to 0 because cos x is independent of h. Cos h minus 1 by h. How it is 0? How this is 0? Will you able to remember the formula 1 minus cos x by x, limit x tends to 0 is 0. This will be 2 sin square x by 2 divided by x. That formula I'm using here. Minus 2 sin square h by 2 divided by h by 2 into 2. This can be written as 2 into this 2 will cancel. So sin square h by 2 divided by h square by, yeah, this is 1 sin h by 2 by h by 2 into sin h by 2. This whole value is 1 if I am applying the limit. This whole value is 0 if I am applying the limit. So the entire limit is 0. So that is the standard formula in the limit. So using this, I can make this whole thing is 0. So cos x into 0 minus sin x into 1 is the final answer is minus sin x. Guys, please go through it. You will feel the importance of trigonometry. You can understand from this discussion. Next class, we are going to wind up the differentiation. Algebra of differentiation. If functions are in addition, how to do the differentiation, what kind of rule I have to follow. If two functions are in multiplication, how to do the differentiation. If two functions are in division, how to do the differentiation. So there we are not going to use the first principle, we will use the formulas right away. Whatever formulas I gave, those standard functions formulas right away we are going to use if they are not mentioned in the first principle. If you are clear with the differentiation, please revise, read the textbook. You will get a lot of doubts. Come with the doubts, you can discuss a lot. So if I am thinking, it's only my point of view. But if you are thinking, 14 students are here. So 14 points of view, you can get the different discussions. So please understand, if you are not clear, please ask me. It's a very important topic for your future. If you are choosing engineering or in +2, it will decide whether you have to learn for marks, whether you have to learn for reversal. If you understand the thing deeply, you will enjoy the subject of calculus. Shall I end up the session, students?
Yes, sir.
Yeah, we'll meet in next class. Bye, everyone.
Thank you, sir.
Yeah.